This is a data interpretation type of question. The information is given as follows. An air pressure contour line joins the locations in a region having the same atmospheric pressure. The following is the air pressure contour of a geographical region. The contour lines are shown as 0.05 bar intervals in this plot, which means if there are two regions A and B and they are connected by a contour line, then it would be indicated that both of these regions are having the same atmospheric pressure. And if there are two adjacent contour lines, then there would be a difference of 0.05 bar indicated by them, which means if this first line is having a pressure of 1 bar, then the adjacent line would be having the pressure of 1 plus or minus 0.05 bar. So this is how it would depend, like we need to take either positive or the negative, but there would be a difference of 0.5 between any two adjacent contour lines. Now they are saying if the probability of thunderstorm is given by how fast air pressure rises or drops over a region, which means we are not concerned if the air pressure is very high or if it is very low. We are concerned with is only if it changes rapidly, which means it was earlier, let us say 5 bar, and then it became suddenly 1 bar. Or if there is a huge number of lines crossing a particular region, then the air pressure would be changing that many times in that area, because between every two lines there would be a difference of 0.5. So if there are four lines, then let us say this was at 1 bar, then this would be 1.05, 1.1, 1.15. So these four lines indicated that the pressure changed by four times of 0.5, so there 0.05, so that many times the difference would be created. Now, in this particular graph, we need to determine which of the following region is most likely to have a thunderstorm. Means the region in which the air pressure is changing very rapidly, or there is a huge difference between 2 points in the same region having different air pressures. So let us have a look at the graph, which is a bit unclear, but we can understand it this way. Let us have a look at this region P. Over here, this is our P. There are just two contour lines. The first one is having a pressure of 0.9 and this one is having a pressure 0.95 because they're adjacent to each other. So the lower one will be having 0.85 or it can also have 0.95. But there is not a huge difference over the region P because there are only two contour lines in these regions. So just a difference of 0.505 being created. So this cannot be our answer. Let us now look at the region Q, and from this region Q we can see that no contour line is passing, so this overall region is having the same air pressure. It is not changing at any point, so definitely there are no thunderstorms possible in this region. Now let us look at R. Over here we can see there is a huge concentration of these contour lines. We can see 1, 2, 3 and 4 contour lines, and this one also touching it. So there are 5 contour lines lying along this region. So the air pressure would change by 0.05 bar between every two lines. So if this is 0.65, next one is 0.7, then it will be 0.75, 0.8 and 0.85. So it is changing from 0.65 to 0.85. So this can be said to be the huge difference between the pressures at the same location. So this region R is more likely to get a thunderstorm as compared to others. So that could be our answer. Let us also look at S. In this region, there is just one contour line intersecting it, and this one is surrounding it. This is having 0.9 and the internal one is having 0.95. So again, that's not a huge difference, just of 0.05. So it's not very likely to get a thunderstorm. So we would go with option C, which is the region R being most likely to get a thunderstorm, as there is a huge difference between the pressures at two different points in the same region. So the answer would be R.